Introduction to Mathematics for Computing, Topic 3, Sets and Operations, Part 2. Okay, we're going to extend our knowledge of sets and set theory by looking at some more tools and techniques used with sets. The first of which will be Venn diagrams. Venn diagrams will give us the means to pictorially represent sets and the relationship between sets, and they can be quite good at facilitating solving problems with sets, once we're not dealing with too many sets, that is. But if there are 1, 2 or 3 sets, Venn diagrams can be very useful. We'll also have a look at the principle of duality. This principle enables us to determine relationships between sets based on some set theory equations. So if we're given a set theory equation, using the principle of duality, we can construct another set theory equation that we know will be true. We'll go on to look at power sets then, and the idea with power sets is that we want to determine a new set. Given a set, we want to have a look at creating a new set that contains all of the subsets of the set that we were given. And we'll end with a summary. So Venn diagrams, as I say, these are ways to get a pictorial view of the relationships between sets and to highlight the result of applying set operations to the group of sets which we are studying. So typically we will envisage a universal set, and as part of that universal set we will be interested in some subsets. The Venn diagram gives us the capability to create a diagram showing the relationships between the subsets and the universal set. So the universal set will typically be represented by a rectangle on the plane, and for the subsets of the universal set we will typically create circles representing those subsets. The different subsets will then form relationships with each other, and we'll go through some diagrams to see exactly how the relationships are formed and how we will actually present them in a diagrammatic form. So the first one we can consider is a subset relationship. So if we're given two sets, A and B, both subsets of the universal set, then we can represent the following relationships between the sets by Venn diagrams. So the first one is A is a subset of B. So in the diagram we see the rectangle representing the universal set. We have two circles representing subsets of the universal set, and these two circles represent the sets B and A. The set A is contained within the set B completely. So in this case, the Venn diagram is representing the fact that A is a subset of B. Okay, so if one set, pictorially, is completely contained within the other set, we say that it is a subset relationship. That's what we want. The next Venn diagrams that we can look at relate to some of the operations we've been considering. So in number 2 here, we see A intersection B, and A intersection B in this case results in the null set, so there are no common elements between A and B. So in Venn diagram form, we would again have two subsets of the universal set A and B, but they in no way touch each other. So A and B in this case are disjoint sets. Their intersection is the null set. There is no overlap between the sets A and B in the pictorial representation. In example 3, we see that A intersection B is not equal to the null set. So in this case we would expect an overlap between the sets A and B. However, we can see that A is not a subset of B. If it was, A would be completely contained within the circle B. And we can also see that B is not a subset of A. If it were, B would be contained completely within the circle A. So this Venn diagram is presenting to us information that says A and B do have an intersection, so there is some overlap between them, but neither is a subset of the other. Example 4 allows us to actually demonstrate the intersection between two sets A and B. So in this case, we would shade in a portion of the Venn diagram that represents the resultant set of the intersection. So we're given again two subsets, A and B of the universal set. We want to present in this diagram that there is an intersection between the two sets, and the intersection would be represented by where the two circles overlap, this shaded portion of the diagram, this portion here. In example 5, we want to represent the union of two sets. So we'll call the union of two sets will be all elements in the first one, and then all of the elements in the second one also. So to represent this operation in terms of the Venn diagram, we again have our two subsets, A and B, but this time we will shade in all of the area of circle A and all of the area of circle B, including the overlap between them. So pictorially, this will represent the union of sets A and B. For the difference operation, again using a Venn diagram, we have two subsets A and B, and this time we want to present information relating to the difference of set A and B. So A difference B, and recall this is all of the elements in A, and then we want to remove any of the elements from A that are also in B. So this results in the shaded portion of the Venn diagram we have here. Okay, so we can see the overlap between A and B, that's removed from the resultant set, because that would represent the common elements. Example 7 gives us a representation of the symmetric difference of two sets, A and B. So in this case, we can see that we want to include all of the elements in A, all of the elements in B, except for those elements that form the intersection. So we can think about this in two ways. A union B, and then remove the intersection, will result in the shaded area we see in example 7. And we saw also previously that another way of thinking of this is take my set A, get rid of any of the elements that are also in set B, and then take my set B, get rid of any of the elements that are in set A, and then form the union of those two resultant sets. This will also give us the set difference. The complement we saw was related to the universal set, and to form the complement of a set A, it would essentially be the universal set less the set A. So U difference A will result in the complement of the set A. So pictorially, in the Venn diagram, we would shade in all portions of the rectangle except those associated with the set A.